Tell you dumb.
Alright, so if I don't want to write that down. If b to the y equals x, okay, so that's an exponential function, right? B to the y equals x, then y would equal the log base b of x. Okay. You know, like addition undoes subtraction, division undoes multiplication, all that sort of thing. Those are inverse functions. Logarithms are the inverses of exponential functions. If you have the exponent that is your variable, you can figure out what it is using a logarithm. Okay. They are inverses of each other. Like 5 to the x equals 25, and that would be written log base 5 of 25 equals x. It's a way to help you figure out what the exponent was. This is exponential form. This is logarithmic form. Okay? They are inverses. Alright, let's look at some of the properties of logarithms.
Can you go over the rules today?
Yeah, we're going to talk about the rules and properties.
I have a lot of log in my Khan Academy.
Oh, yeah?
Yeah, that was easy.
Good. This should be for you. How do you like that?
I guess you did that maybe.
Up there, too.
Do we have school Friday?
We have school
I
Friday.
have school Friday. Oh, we didn't have school Friday.
That's cost on that.
Thanksgiving breaks next week.
Wishful thinking, I guess.
Nothing is Friday. That's why we have school.
Doesn't that mean?
Alright, so product property. Oh, Stephen. Log base b of m times n. Okay? Multiplication turns into addition. Log base b of m plus log base b of n. I'm going to tell you, these properties are useful when you are trying to manipulate and change up logarithms. I think I told you about my school teacher, Mr. Matt, who would not let us use the calculator. If we used the calculator, it was one that was like this big. It was like, yeah, it was like this big, and it looked like a credit card. That's about how big it was. It was thin, and your fingers were always fatter than the buttons were, so you'd have to try and use your pencil lead, and then you'd yell, "Put that pencil on my calculator." Anyway, you could not do logarithms on the calculator. To do logarithms, you get a chart, and the chart would have all the common logs on it, and common logs or maybe natural log, I can't remember. But anyway, you would have to use that chart to find your logarithm. And it went from 1 to 100. So if you needed, like, the log of 250, 250 went on the chart. You couldn't find the log of 250 on that chart. We could find 25, 10. 25 times 10 equals 250. So what we would do is we would look up on the chart log of 25, and we would look up on the chart log of 10, and then we would just add those two together. And that would be the same as the log of 250. So that's how these properties are actually used.
Do you have a chart?
I have a chart. Yeah, I'm going to give you the properties today and just let you work on expanding them and condensing them. And then I'm going to give you a chart and make you find them on a chart. So that was the product property. The two numbers multiply together and make that number.
So it would be 5 plus whatever log of 10 equals.
That's not 5. That's not base 5.
Oh, that's right.
It's base 10 right now. 10 is 1. That's 1. Alright. Can I move this? We're going to do a quotient property. Quotient in. Alright, so if multiplication turns into addition, what do you think division is going to turn into? Yes, subtraction. That is correct. Let's say we have a chart log base B, and we need 2/3. 2/3 is not on the chart. It's whole numbers from 1 to 100. So we would just change this to log base B of 2 minus log base B of 3. And find those two on the chart and subtract them. I'm on just says police investigating. Probably document. I didn't say where. I just don't understand. Like, if you're gonna rob something, rob like Sephora or I mean, Dollar General. You gotta be hard up, right? You're going to go either way. Make it worth your time.
I honestly think mine's gonna get caught.
No, most people get caught.
Yeah.
Especially around here.
They're gonna relax first.
Alright, so back to this. Power property. Okay, so let's just think about this for a minute. Multiplication became addition. Division became subtraction. What do you think of power?
Put it in the front of the
Yeah,
log.
it's gonna become multiplication. It's gonna go in the front. It's gonna be like P times whatever log base B of n is. How do you think that would be useful if I'm using my chart? If I have my chart, how does that help me?
I thought you like half a log is that half a log.
Yeah, what if I'm trying to find the log of 625? Not on the chart, right? So you 25 to 100 level quality system thing. So equal a log of 25 squared. 25 is on the chart. So that would just be 2 times whatever that log is on the chart.
Are we gonna solve for that later on? Okay.
We're just going to manipulate them today. We're going to simplify them later. Now let me just go through like some basic properties. Are you finished writing this one? If m equals n, then log base b of m equals log base b of n. But I know that sounds kind of like duh. And reverse. If log base b of m equals log base b of n, then guess what? You're never going to get it. Log base b of b equals 1. That's because that's anything to the first power is itself. Log base b 1 equals 0. Anything to the 0 power is 1. Log base b of b to x equals x. All this, which is 1, it just goes away. And b log b. Alright, so let's expand, condense. Let's practice some of these. Let's do them. Remember what button on your calculator that E is over?
Yes.
What is it? LN, right.
Is natural log the same thing as log?
No, natural log is the base of, or natural log is the inverse of E.
The thing that I was having trouble with was like it was said on log base 9 and then like x equals 20 27. I think I was having trouble with it.
I want to show you these two right here I want to graph these on Desmos. Show you how they are different. I'm going to keep recording it though, so the people at home, our home viewers, can also see what's going on. Alright, so here they are. These are the two inverse functions. The red one is e to the x, the blue one is the natural log of x. Can you see that? Okay. You can see their inverses. Remember, on an inverse function, the x's become the y's, and the y's become the x's. So, like, look at this point. This point is the y y-intercept 0, 1. Over here, it's an x-intercept at 1, 0. They just switch. Every point that's on here has switched to the point that's over here. Anyway, so they are inverse functions. Natural log is the inverse of the base of e. Is the base. Alright? So, I just wanted to show you that because that's not one that everyone is familiar with. So I wanted you to see how those look. Alright, let's expand or condense or let's just do something. Gosh, let's do something. You can, what did you say that problem was on quantitative that you couldn't get?
I got the answer, but I just had trouble with it because I like so many of those.
Okay, what
So
was it?
9, and then x equals
9 to the x?
like log base 9, x equals
Log base 9
equals 27.
equals 27. Okay. Alright, change it to an exponent. That looks like a different exponent. I don't think that's right.
I don't think that's right either. I think it's log base 9, 27 equals right. So the exponent would be 27.
The exponent would be the x.
Yeah, that would.
So you're looking at 9 to the x
Right.
equals 27. Right? Both of these have a base of 3. So this would be 3 squared times x. This is 3 to the third. So 2x equals 3. So x is 3 over 2.
I'll tell you something.
How you solve it? Here's the thing. They're inverses. If you were given a logarithm to solve, turn it into an exponent. These are inverses. If you're given an exponent to solve, turn it into a logarithm. These are inverses. Like if I give you a multiplication problem to solve, you turn it into division to solve. If I give you an addition problem to solve, you change it to subtraction to solve. These are inverses. So whatever you're given for one, turn it into the other to solve. Because they invert each other. Okay, for real, let's expand something now. How about, let's start pretty easy. How about, who has easy problems?
They were complaining because they thought I had easy problems in my Khan Academy.
Oh, because you cheated?
Yeah, because I cheated somehow.
That's a 2. It looks
You
like
do
it just
it.
got like a 2. 2.
Okay.
Alright, so I've got a couple things going on here.
You can give me the answer.
Not yet. Let's go step by step. First of all, let's bust up that multiplication. So what's multiplication going to become? Addition. Log base 5 of x plus log base 5 y squared. Alright, is there anything else that can be expanded from that?
Yes.
What?
The exponent.
The exponent. This can go here. Log base 5 x plus 2 log base 5. Anything else can be expanded on there?
That's it.
We're done. Alright, what do you want to do first?
Take it out.
write square root of y as y to the 1/2.
Then you take out, you put one back in for natural log.
Not yet. This is 2 times y to the 1/2. So this has to be split up also. Like that. I want to show you something with division that some people kind of mix up sometimes. Anything that's under that bar has to be subtracted. And that goes back to like negative exponents go below the fraction bar. So if you had like log of 3x over w v, I don't know, let me add one more q, not in order. All 3 of those have to be subtracted. Like, well, they're being multiplied together. I know that. So you have a couple ways that you can do that. You can say log of 3 plus log x minus, and then a parenthesis where all 3 of these are being added. Because what's going to happen with that minus sign?
Negative. They're going to be negative.
Right, every single thing is going to change to negative. So you can do like this, but it's not really completely simplified, because simplified means that you have no more parentheses. And the answer, the end-all be-all answer, would have these 2 being added as positives, and then everything that was under the fraction bar would be a negative. So just watch out for that, because a lot of people get confused because they're like, well, that's all being multiplied. Multiplication is addition. You're right, it is. But you have to distribute this minus sign right here, so they're all going to change to negatives. Let's try condensing that. Split down. Alright, so smush that one back together. You can do these things to try it on your own. Option. Right, what do these things go?
X exponent.
So the natural log of x squared plus the natural log of the square root of x plus 4. And what about
And combine together.
natural log of x squared.
The game is here, right? Or the BSC?
Yes.
The BSC?
5 o'clock, that's great. Not on me there. You take a shot, here it comes.